Hi, Bob here with JD Squared. In this video, I'm going to answer a new customer's question. I've done it in the past, but what we're trying to do is make playlists for like the new rotary cutters, the XR6, XR12, and even all the rotary attachments and everything. Now, the video I'm getting ready to make is about Camelot, and it's how to design a basic roll cage in Camelot real quick. It's fairly simple. But I want to go through it step by step as if you kind of don't know anything. Anyway, sit back, grab your coffee, tea, or whatever. And if this kind of thing interests you, I hope you enjoy it. Let's get started. Since this is a video for newbies, somebody with virtually no experience at all with Camelot or a rotary cutter, I'm going to go through a lot of the steps. Now, the first step you're going to need to do when you install Camelot on your machine is just make a few basic settings. So to do that, we're going to go to the settings panel. We're going to select units first, and we're going to pick our units. Now, I'm going to select inch, but you can see we have millimeter if you're on the metric system. But since the material I'm using out there is inch, I'm going to use inches. So I'll select that. The next setting I want to change is I'm going to go to the select or settings button, click it. I'm going to make sure under the machine tab that I have the correct power unit, the plasma cutting power unit selected, because that's how Camelot will find out what consumables are available for different thicknesses and kinds of material like mild steel or aluminum. So I'll pick Power Max 85. Now, over here, we've got another tab. We've got import units. You may want to select always ask for imports. The reason is because a lot of people that use our machine are importing step files from other programs, and some of them, they don't know if it's metric or inch. So you can imagine bringing something in that's 500 millimeters long, or let's say 1,000 millimeters long, which is about 39 inches. And you bring it in as an inch, and all of a sudden your part is 1,000 inches long. A little bit of a difference right there. So what I like to do is if I'm importing things that was created by other people, I want Camelot to ask me, what are the units? If you also see an imported part where it just doesn't look right, there's no way this is right, the odds are it was imported with the wrong units. Just go into, once you get your part imported, just change the units to the appropriate measuring system, and you should be good to go. All right, now you got visuals. This stuff is all nothing that you really need to worry about. I wouldn't worry about anything. Okay, let's go ahead and say okay. That takes care of that. Now, the next thing we're going to want to do is check our profile library. Before I can design my roll cage, Camelot has to know what we're going to design it out of. So I'm going to go to Settings, Profile Library, click on it, and that brings up the library. Now, the profile library is where you're going to store all the dimensions of all the material that you want to process in Camelot. Like, for instance, if you're working with a frame, you're creating a frame, you're editing a frame, or whatever you're doing. So this is the profile library right here. Now, what I'm going to do is I'm going to go ahead and click on OD to sort that column, and I'm looking for 1.5 inch right here, round, right? I got 1.5 inch OD round. I've only got 2 entries. Neither one of them is the one I want. I plan on making this cage out of 1.5 inch OD tubing with a 120 wall, and I'm going to bend it on a 5.5 inch die in our JD Squared bender. I don't have that entry, so I need to add it. So I'm going to pick any field I want to, any select setting, and then I'm just going to modify the fields, and I'm going to add it to the list. So let's go up here, change the radius of the forming die to 5.5, and I'm going to say 0.120 wall, mild steel, and that's just a description field. It's going to go into this column over here. Make sure I've got my 1.5 inch OD, my 120 wall. Now, if I was dealing with square tubing, I would be putting that information into this section here. I also have general profiles. That's the subject of another video. That's like later on we'll be adding C-channel, things like that. But right now we're dealing with round tubing. Now lead in, I'm going to type in as 7/8 of an inch, and that is the distance from the saw cut edge of your die, the flat edge, to the tangent point of the die. Now tangent is when you have a round circle and you have a straight line that is touching that round circle. No matter where you roll around that arc, wherever that line touches the circle, that's called your tangent point. Now, obviously, when you're bending tubing, it's going to start at that tangent point and it's going to bend down, right? What the lead-in is the distance from that tangent point to the flat machined side of the die. Typically, we do that at 7/8 of an inch. If you look up the JD squared video on YouTube that's got K-factor or profile library in the title, it'll talk about this in more detail. I just wanted to throw that out there to you real quick. Achieved CLR, centerline radius. Whenever you bend a piece of tubing, it's going to bend, and then it's going to spring out as soon as you take the pressure off it, bend it, and it's going to bounce out a little bit. That's called spring back. In our experience in 40 years of building tube benders, if you're dealing with tubing, mild steel tubing, under 2 inch, a good rule of thumb is an 1/8 inch. It's remarkably close. So I'm going to go ahead and use that right now. So I'm going to type in 5.5 inch plus the 1/8 inch, 5 5/8 of an inch. Now, K-factor, once again, go on YouTube, search for video, JD squared, K-factor. It'll explain all this. And I'm going to set that value at 0.5 because the K-factor, and that's, by the way, real fast. I can show you better with the K-factor calculator. Let's go ahead and type in a number 24. This is how you would calculate the K-factor, by the way. Put in the OD, put in the achieved centerline radius. K-factor is the percentage distance from the inside of the radius, right here, that'll be 0, all the way to the outside radius, that is 1, right? So it goes from 0 to 1, 1.0, but it's a percentage of that number. So if you bent this tube, you could tell whenever you bend anything, by the way, the inside is going to compress. It's going to shrink down. The outside is going to stretch. Somewhere in between the stretch and the compressed side, there's going to be a point that's called the neutral plane where the tubing or the workpiece neither stretches nor compresses. That's the K-factor. So if it's 40% of the way from the inside here up this way, the K-factor is going to be 0.4. So that's your K-factor right there. Centerline radius, of course, is showing you right here, the CLR. That's going to be in the middle of the tubing always, you know. All right, so let's cancel out that. So I put 0.5 because I do not know what it is, and that's a good visual indicator to me that I need to go test this, because what's going to happen, if you put in the incorrect number for a K-factor, let's just say 0.5, the Camelot is neither going to add or subtract a length to the tube that you need to accommodate stretching or compressing. Now, when we bend this, the bend is going to stretch, which means in the real world, we need less tubing than we think we need because it's going to stretch in every place that you bend it. That's why the K-factor is important, and that's why I set it at 0.5 right now, because it'll tell me you don't really have the real number. It's easy to find the K-factor. Once again, search for JD squared K-factor on YouTube. It'll show you everything about it. Now, what I'm going to do is I'm going to go ahead and hit the add button. Now, if I go down here at the bottom of my list, there's my new profile added right there. Now, the other size tubing that I want to bend is going to be 1.25 inches. So we'll make the main cage out of 1.5 inches, all the crossbars, everything like that, we can do out of 1.25 inches. Now, you notice my new entry is here, right? Let's go up to look for 1.25 inches now. I'm going to click on it one more time. I clicked on it, it reversed the sort order of this column. So I'm looking for 1.25 inches. And I've got it right here. And lo and behold, that's the one we're going to use. We're going to do it out of 0.9 wall, 1.25 inch tubing on a 3.5 inch bending die. And you can see all the information over here. And you can even see the profile shape, by the way. It'll give you a heads up. So we're good. Now, we're going to start this roll bar design process with the main roll bar. We're going to make that 1.5 inches. So what I need to do is select the 1.5 inch, 5.5 radius, 120 wall, and close and make the selective profile active. So let's do that. All right. Now, the active profile is what Camelot is going to use whenever you create or modify a tube. So let's say you're going to create this roll bar and we start drawing points, how to define it. It's going to do it with the active profile. Now, later, if I make that die out or that bar out of 1.5 inches and I go, I don't want that, I want to make it out of 1.25 inches, then I will select the 1.25 inches in the profile library, make that active, and then when I modify the other tube, it will switch it over to 1.25 inches. Okay, I think that's all you really need to know about the profile library. Let's go ahead and create our frame by selecting in this panel up here, the Create Frame button. Let's give it a second. All right, there we go. All right, now when we create a frame in it, obviously it's going to select the active profile, and it's showing you right over here that we have 1.5", 5.5 radius on the bending die, 120 wall. That's all the information I filled out. Notice here it's saying true. That's because I had this selected under the profile library. Bring it up real quick. The in stock button right here, and it's telling me that I've got that die. Now if I didn't have that die, it would be false right here, and that would just tell me that you either need to change your bend radius or you need to buy that die or find somebody who has it. So that's what that means right there. All right, let's go ahead, and obviously we got to add a tube to make our roll bar. We're going to do the main roll bar first. So I click on add new tube, it brings it over here. Now what Camelot's going to do, whenever you create anything in a CAD program in 3D space, there's going to be a point where it's called X0, Y0, Z0. And the way 3D space works, you're familiar with it, you walk around, you can either make left or right, let's call that the X-axis, and you can go forward or back, let's call that the Y-axis, you go up and down, we'll call that the Z-axis. Well, where you happen to be standing, if you're right in the middle, you're at 0, 0, 0, which is on the floor right here. Now that is what the coordinates for the very first point of what we're doing, Camelot is assigned this to, right? But here's the trick. I want to make this roll bar, and I kind of want to make it symmetrical. That's how I'm thinking about it in my brain. So, and I'm thinking that we're going to make this roll cage 60 inches wide, 5 feet wide. So I don't want to start at 0, 0. I actually want to start at Y minus 30. And the reason is that's half over from, so that'll put the center of the roll bar in the middle of my part. So let's go zoom out a little bit. Okay, now we're going to go ahead and we're going to add a tube, and you're going to see what's going to happen. And I'm going to say I want to go up a certain distance. Now in Camelot, you can do that in a couple of different ways. One way is you can tell it to go an absolute distance. And what that means is no matter where you're at, the point in 3D, which has an X and a Y and a Z component, wherever I tell you to go to that point, you absolutely go there. So let's just say I came along and said that on the Z axis, absolutely, I want to go up 24 inches. Okay, let me zoom out a little bit more right here so you can see it. There's our first bar. It started at this point here, which is the minus 30, because remember we're going to make this thing 60 inches wide, and then it went up 24 inches. I could have done that also by telling it that it's relative, and I'll show you what that is on the very next point. Let's go ahead and add another point at the end. And what we're going to do is we're going to tell it, I absolutely want to go to 36 inches. I measure the inside of my car. I absolutely want to go to that height. Now, all these dimensions are off the center line of the tubing, not the outside of the roll cage or the inside of the bar, the middle. And the reason we do that is because that's the way everybody does it. If you look at a frame editor and in SolidWorks, Inventor, Fusion, Creo, whatever you're working with, they're all working off centerline components, and we do too. So that's what you're going to see there. Now, so we're going to say we're absolutely going to go there. But this time, I don't want to do all the math in my head. I want to move in. I want the roll bar, you're going to see what it's going to look like, but it's going to be kind of like this. And I want to move in 8 inches. I've got inside my car. I've measured it, and 8 inches is my number. So I'm going to look right here on my Y-axis indicator, and I'm going to say I want to relatively, from the point I'm at, I want you to move over 8 inches. So now, if we look at it, we end up with that right there. That's exactly what we want. Now notice it's put a bend in it, right? Because it looked up the K factor and it looked up the achieved centerline radius, and it went ahead and did that for you. Now I could say I want to miter this if I wanted to too. I'm sorry, wrong point. Let's go back. Let's go back one more point, the one that says bend in it. And if I change this to miter, you would end up with a mitered point that you see right there. That's not what we want. We clearly want a bend. So let's put it back to a bend. Okay, that's our first point. Now we are going to move over to our next point. However, what we're going to do is we're going to add a point at the end, and this time we'll go absolutely in the Y direction. We're going to move over to 30 minus the 8 inches that I did earlier. So I'm only going to go over to 22. Let's go ahead and do that. Bam, there's my 22 right there. Let's go ahead and notice it put the bend in for us. Let's go ahead and add another point at the end. I'm going to go back absolutely to 24 inches above the ground. However, I am going to move over relative on the Y 8 inches, which was the mirror of what I had done over here. So we're good to go, right? So that's that point there. Now for the final point, all I've got to do is say, go absolutely back to the floor, you know? So we'll say, do that. And there's our roll bar. Now we can go ahead and close this, apply and close, and there's your roll bar. That's all it took to do that. Now, if I want to edit this roll bar, I can go back into edit right here, and I can start making changes. So for instance, I can say I want to edit the frame, and I can start changing things if I want to change the dimensions or whatever I happen to want to do. So like this one here says 8 inches, right? What happens if we say go 20 inches? I'm just showing you here now. So we'll say, okay, your roll bar changes. That's the beauty of using relative things to where you could easily change the entire thing. So for instance, if I wanted this roll bar larger, I could change some of the other dimensions too to take this exact roll bar and change its shape. And then I could use the profile library, for instance, to change it to a completely different tube. So keep that in mind. In Camelot, we're probably not going to be adding a feature that you see in some programs, like for instance, one that BenTech puts out, where you have templates in it. We're not going to do that because you don't see that kind of stuff in high-end CAD programs. What you do is you create a model like this roll bar, and then you just copy that model, and then you modify the dimensions, and there's your new roll bar. Much, much better than filling out templates, because templates will pigeonhole you into a particular shape. If you didn't want that shape, well, that's just too doggone bad. Whereas doing it this way, we don't care. You just make the shape whatever you want. That's why at JD Squared, we're not a fan of templates, but never say never, you know. Anyway, that's our roll bar. Now what we're going to do is let's go ahead and add some other tubes to this roll bar. So to do that, we're going to go ahead and edit our frame. And we need to, let's see what we're going to do here. Let's go ahead and we're going to add 2 bars that are going to join just inside of this bend right here, and they're going to go to the rear diagonals, whatever they called. Let's go ahead and do that. Now, I need to edit my frame by clicking here, and what I'm going to do is I want to click on that point right there, and I'm going to use a feature called reference points. Now, whenever you add tubing to Camelot or whatever, you can add it at a particular location. And by the way, when I earlier said X0, Y0, Z0, I know that point is called the origin for some of you that are in the CAD program. I was trying to keep it simple for newbies, but technically this 0 point right here is called the origin. All right, anyway, I need to add a reference point that I'm going to connect my next tube to. Now, the way you do that is you select the point where you're going to want to put the reference point after, and I add a reference point on the part. I could do it on a bend. I'll show you how that works here in a little while, but right now we're putting it on the straight part. Now, what it does is Camelot basically assumes that you're going to want to support that straight length. And where do you normally support a straight length of anything? Usually in the middle. So it automatically put the point in the middle, but that's probably not what you want for a roll bar. So what I'm going to do is I'm going to unselect percentage value, and that will move me into a distance value. So right now it calculated the middle of that roll cage from that point is 22 inches. Makes sense, right? 30 inches minus the 8 inch that we leaned in. But we're going to do a little bit different. We're going to say, I want you to come in at 6 inches. Let's see what that looks like. Okay. Let me hit enter. Okay. And that don't look too bad. That's probably where we want to be. Now, I may want to even move over a little bit more. Let's go, let's say 4.5 inches. Let's see what we got there. I like that better. We're going to go with that as our first reference point. Now, let's go back to this, back to our point before the reference point. We're going to add another reference point. But this time, I want it to be that 4.5 inches from this point. Now, the way you do that is you're going to say add reference point. Okay, it put it in the middle again, right? We're going to unselect percentage. By the way, if I did want to use a percentage value, let's just say, for instance, I typed in 75% here. You can see where it moved it over 75% of the distance. Let's go ahead and unselect that. And we're going to put our 4.5 again, right? Problem with that is it's going to put it on top of the other point, and we want it over here. So all we have to do is select distance measured from the next point. There's our next reference point. So we're looking pretty good. So let's go ahead and close that right there. Now we're ready to add our rear diagonals. Now, another thing you're going to want to do is save your work. So I'm going to go ahead, apply and close. And that's our roll bar right there. Notice over here, it's actually showing you all the bins and everything. And here's your in stock. If any of these were red and had the word no, that means you don't have that die. You better make a change to something. That's relatively easy to do. Probably subject of another video, but it's easy to do. Anyway, I want to go ahead and save the active view. And let's just call this roll cage. Now I've got to move it into into the correct folder here. Bear with me, please. We're going to put it into this here. We're going to put it right there. And we're going to save it as a JD2 frame. So now we have that frame we can come back to. And that way, if anything goes wrong, we'll be able to recreate our steps. All right. Now, the next thing we're going to want to do is let's go ahead and add some rear bars to this thing. This is a very generic roll cage. I'm not trying to be too fancy here. I'm just trying to answer a lot of questions. And the customer who purchased the XR6 specifically wanted to know how to do some of the things that I'm getting ready to do. So hopefully it works for everybody. All right, let's go ahead and add the next two tubes. We're going to make this also out of 1.5-inch tube. So what I need to do is add a new tube, but this time I want to start at that point right there. So I am going to click driven by point, and I am going to select that point right there. Now I'm going to add another point. This time I want to absolutely go to the floor. This is a quick, simple example. So we're going to go to the floor. But I think relative, I'm looking at my axis right here, X. Let's go to, whoops, better modify that. Let's go back, and I hit the wrong doggone button. Let's go back to relative right here. And I don't want to be at 0. I want to be, let's see, how far back do we want to go, guys? Let's go back 40 inches. You know, now I think I had to type in -40. Let's see what happens here real quick. Yeah, there we go. Okay, that's our bar going back that way right there. So that's our first one, right? So let's go ahead now and add another tube. Once again, we're going to drive it from here. We're going to add a point. We are going to go to the floor again. And relative, we are going to go a little bit too quick for me right there. We're going to go -40. And that's our two rear bars right there. Now notice I haven't coped anything yet. I'll do the coping after we get the cage into the machine right here. All right, so we're looking good. We've got that right there. Now what we want to do is let's go ahead and put some, what kind of bar are we making here? We going to put any kind of front on the bar or not? Yeah, maybe we'll add it here. Yeah, let's go ahead and add it. What the heck, we're here, right? Let's go ahead and add a new tube. Once again, I'm going to select a point that I want to drive from, and I'm going to select this point here, and then I'm going to add a point. Now this time, relative, I want to come forward. I'm just going to say 30 inches. Not really sure, but this is what we're going to do. So let's do that, and you see the part popping out. Let's go ahead and add another point at the end. And I've got in my car and I've measured everything, and it turns out what I'm trying to do is I'm trying to come down the windshield maybe, you know, or something like that. So let's say we're going to move over I don't know, I'm just going to make up a number, 10 inches. So we had 30, now we're 10. But this time we're going to go down to our 24 number. Let's see, 24. That's going to bring us to there. And then we're going to add one more point, and we're going to go to back to the floor. All righty. So we now have that right there, and we can add our next tube. Once again, we're going to do the exact same thing. This time we're going to select this point right here. We're going to add our point. We're going to go relative 30, same as I did earlier. I'm going to add another point. I'm going to go relative 10, and I want to go absolutely to the floor. Okay. I'm sorry, not to the floor, back to our 24 inch. And then I'm going to add our final point. We're going to go back to the floor. And that kind of gives us that. Now I can go ahead and close it, apply and close. And that kind of gives you your rough roll cage right there, you know. Now let's go ahead and add the supports. Once again, very quickly, I'm going to go up here to File, and I'm going to save the active view. Alrighty. Let's go ahead and edit our frame to add our smaller parts. Now this time I'm going to go ahead, select active profile, but I am going to go ahead, sort by OD, makes it a little bit easier for me to find, and I'm going to pick that 1.25 inch tube, and I'm going to close and make selective profile active right here. Alrighty, notice it's changed it right there. Alright, let's take a look here. Now what the customer was specifically asking was he wanted to have an X bar that went from the middle of this bend over, you know. So he wanted to know how you would do that. And once again, we're going to be using that feature that we talked about earlier. That is the reference points. Okay. So let's go ahead and add those reference points. So we're going to edit our frame, and that's the tube we're on right there. So it'll show you all these points, right? This time we're going to select this point. I'm sorry, I'm going to select this point, and we are going to add a reference point on the bend. I just noticed it says on bent. Our previous developer, no longer with us, is out of the Netherlands, and he does a good job speaking English. But, you know, few of the nuances. So we're going to change that to bend. Anyway, we just added a reference point, once again, right in the middle of the bend. Now, we could have done that exact thing we talked about earlier, to where I could have said I want it 25% up the bend. It'll calculate. Or I could have said I wanted a few inches up the bend. But we're going to go with the 50% because he said he would like to see it in the middle. You know, so we'll do that. Okay, now what we're going to do is go ahead and add another reference point. Let's go ahead and find our point right there. We want that reference point also to be in the middle of bend, because remember, the existing point is actually the intersection of this line and that line, so it's really not even part of the tube at all. So let's go ahead and add a reference point on the bend. Once again, it'll put it right in the middle. There we go. Now, let's think about, and I didn't really have a great description. Somebody just came in my office and said, hey, Bob, can you pop out a video to show this gentleman how to do stuff? Let's go ahead and put, if we're going to cross it this way, let's go ahead and put a reference point somewhere in this neighborhood here. Now, the way I'm going to do that is I'll go to my second to my last point, this one right here. I'm going to add a reference point on the part, but I don't know if I want it up that far. Let's do this. Let's say we want it down, we'll say 4 inches. Let's see what 4 inches looks like. Yeah, that actually looks pretty good, don't it? I could live with that. We're going to connect from here to here with that 1.25 inches. All right, let's go ahead and add another reference point. This time, we're going to do it from our first point, and we're going to say, add a reference point on the part. And we are going to, what did I do? I did 4 inches. Is that what it was? We'll do 4 inches, but we're going to measure the distance from the other side because we want it up in this area here. And we'll say okay. Now, let me go check something out real quick. I want to make sure, yeah, 4 inches right here. It even says 4 inches. Okay, we're good to go. All right, so that's our 2 points there. Let's go ahead, close this out, and let's add our tube. Now remember, we've already selected the 1.25" active tube. This time we're going to drive from this point. We're going to add a point. We're going to select driven by point. We're going to pick that one. Notice it puts a dashed line to show you what's going on. And that's our next point. Now notice if I rotate that it is a smaller diameter tubing, it's 1.25" compared to the 1.5". So that worked out real well. Okay, what we need to do now is place another reference point. You live and die by reference points, don't you? We're going to select this tube here, and we're going to select this, and we're going to add a reference point on the part. It's going to put it in the middle, and we're going to say that's good enough. Now let's go ahead and add our new tube, and this time we are going to drive from this point. Now we're going to add another point, and we're going to drive to that point right there. Now let's go ahead and add another tube. This time we're going to drive from, let me rotate around here, this point right here. Let me zoom in, hopefully you can see it better. And we are going to add a point, and we're going to drive to this point right here. Now, I'm looking at it right here. Looks like that isn't exactly really where we kind of want to be. So let's do this. Let's hit Control Z, back out of here. Let's add a tube, and we're going to drive it from this point here to this point right here. Let's see how that works out. Okay, did I do that right? Oh, I'm sorry. I hit the wrong button. I went too fast again. All right, let's drive. We'll go there. Okay, that's our bar right there. So that's the actual crossing point right there. And it probably has to do with we're in the middle of the bin here. We're not really in the middle. Okay, so we've done that. Let's go ahead and take a look at it. I think he also wanted a bar coming across this way here. And on that one there, let's go ahead and add us another reference point. We're going to close, and we're going to select this one here. Let's edit the frame. And this time we're going to add another reference point. Let's see, on the part. But we're not going to go all the way up to the 4 before it. We want it down below, a little bit below that point. So we're going to say we want it, let's say 6 inches from the other end. And let me zoom in and see what I've got there. Yeah, I think that's probably going to work fairly well. That'll allow us to weld around both coped pieces of tubing without too much trouble. Now, this time I'm going to do something a little bit different. Yes, I could have created another reference point over here, but I really don't have to. What I'm going to do this time is I'm going to close out of here. I'm going to add another tube, and I'm going to go from my reference point here, but I'm going to drive it from this point right here. This time, I'm going to add a point, and I'm just going to say move over relative in the Y direction 60 inches because we know how wide the cage is, and that's what I did right there. Okay, I believe this is kind of what he's looking for. I think he mentioned he wanted to put an X back here. Let's go ahead and do it. We're here, right? Let's go ahead and select this tube right here. We're going to go ahead and add a reference point on the part. And this time we're going to use a percentage value. We're going to go up 25% or down 25%. And let's go ahead and add another reference point to the part. In fact, actually, I don't really think I like that much. We're gonna try something a little bit different right here. Let's go ahead and take this particular one and say that it's going to be let's see. I want it very close to the top up here. Let's, you know what? Let me back out of here. I think I went a little bit too fast. I hit Control Z, by the way, undid. Let's go to this reference point right here and make it 75% of the way down. So we basically just added that point, right? Now let's go ahead and add another reference point. We're going to select this tube. We will add a reference point on the part. And once again, we'll do that 75%. We'll hit OK. And there we go. We have both of our parts. Now let's go ahead and add the X in the back. So we'll close this. We're going to add a new tube. We're going to drive it by a selected point. It's going to be that. And I'm rotating, by the way, by using my left mouse button. And then we are going to zoom. We are going to add a point. And it's going to be driven by this point right here. There you go. Now, let's go ahead and add another tube. We are going to drive from this tube at a point, and we're going to drive to that point right here. That's our X right there. Let's go ahead and close this. Let's apply and close. And let's take a look and see what we've got. I believe that's what he's looking for. Now, we haven't coped any tubing yet, but this should be what he's looking for. All right, let's go ahead and start coping these tubes. In order to start coping these tubes, we've got to split a couple of them. So let's go back to our edit menu. And if you look right here, we have one tube and one tube. They're crossing across each other. Same thing back here on the rear. We have those two tubes. Well, we got to split two of those 4 tubes in order to cope them. And what we're going to do, we're going to just select split tubes. And then we're going to say select the tubes to split. We'll select this one, and we're going to select what we're going to split it with. This one, hit apply. Now, if we select it, you can see where we have each tube, but it's also pre-coped the one tube for you because it figured you're splitting it. You're cutting it across another tube. Let's go ahead now and do the same thing. Then we'll split this one, and we'll split it with that one. I'm sorry. I have to select the split tubes to select. We're going to select that one, and we're going to split it with this one here. Apply it. And there we go. There's our other cope right there. We've split that tube too. Okay, excellent. Let's go ahead now and start coping the rest of the tubes. We go up to cut tubes, and we're going to cut tubes. We're not going to cut tubes with a face. I will show you how that works here in a little while. But when you cut tubes with a face, what it means is you're going to cope the tube to a flat surface. We're cutting tube to tube, so we're going to select cut tubes. Alrighty, it says over here, it's highlighted in blue, select shapes to cut. Let's go ahead, zoom in a little bit so you can see. We're going to start with this one. And now we have to select the cutting shapes, what we're going to cut it with. And we're going to cut it with that one there. We hit apply. And if I zoom in here, you can see there's your cope right there. So let's march around and knock off the rest of these. We'll go ahead and select this one. We will cut it with, rotate so I can see a little bit better. That one, apply it. Alrighty. You can see the cope right there, that it's got it on it. Alrighty. Let's go ahead and get this one out of the way here, but this one we're going to do something a little different. I'm going to select the button, cut with all others. Now if I hit apply, it's going to do both ends at one time. It's a time saver. All right, let's go back here to the rear. We are going to cope this one right here. And let's undo that cut with all others. And we're going to select our cutting shape, which will be that. We'll hit apply. Now, yep, that coped. Let's go over to this one, select cutting shapes, apply. Alrighty, that one's coped. Let's come over here to this one, and we are going to say, let's try something here. I haven't even tried this. Let's cut with all others. Let's see what happens. So I didn't split the tube. I think it's going to drop one end out. And look at that. Oh, pretty neat, pretty neat. Yeah, it did it right there. So that's coped there, and it's coped here. So that worked out extremely well. Let's go ahead and do the other side. This side here now, we're not going to cope with all others because we've already got one cope side. So we're going to select the cutting shape, hit apply. Now that one is coped on both sides. Now this one is the little more interesting one. We're going to cut a face. So let me move it up. We're going to cut it, of course, with multiple objects. So I'm going to hold down the control key. I'm going to select this one. Oh, I'm sorry. Let me redo that. That's your cutting. That's the shape we're going to cut. I am going to cut it with this one. Hold down the control key and that. And you could see where that particular tube is cutting across two other tubes. Let's go ahead and hit apply. And there you go. That's your cope right there. All right, let's see, we've got that one's out of the way. This one's good. All right, now we got to go ahead and let's do this one. Now this one I will cut with all others, and we should cope right here. and here. That's excellent. And this one right here, we are not going to cut with others. We're going to select that, and we're going to cut it with that bend, apply. And let's do the other side. We'll pick this one, select cutting edges, this one right here, apply. And I think we've only got 2 other edges to cope. Let's take a look here. Yes, I think we're looking really good. Alrighty, the 2 that we got to cope are going to be these rear down tubes. So if I go like here, you could see where, remember I added the extension earlier to it? We need to cope this off to be flat with the ground. Now the way we're going to do that is we're going to go to the grid, we're going to make it visible. Now check out my other video on YouTube that talks about Camelot and grids. I will be adding it to the playlist. Like I say, I'm trying to organize everything, make it easy for you. But if we look at this, from a sideway point of view, you can see where these tubes come through the floor. We have to cut them off flat with the floor. Now to do that, we're going to go back to tube. We're going to say cut tubes, but we're going to cut it with a face. And what we're going to do is we're going to select use grid as cut plane. Now, if I zoom out a little bit here, you can see a down arrow. That's the side that it's going to cut. Let's go ahead, select shapes to cut. We're going to pick this one, hold down the control key so that I can select multiple items. Cut 2 parts. And that's it. Let me go back over here to the grid, turn off the grid, and back to our tube, and there you go. Let's see. Everything should be done. See how nice and flat it is right there? So let's go ahead, hit apply and close. And there's our roll cage right there. You can see where we are cut off flat with the floor right here. Everything looks real good. Now, one other thing I'll show you about coping here pretty quick. Let's go ahead, go back to edit. And this time I want to remove, let's just say you wanted to remove a cope for some reason. You know, there are times when you may want to do that. Let's go ahead and go to cut tubes and remove cuts. It says select the tube. I've already got it selected right here. Delete the cuts. If I zoom in, you can now see how we no longer have the cope. I'm going to hit Control Z to undo that uncoping operation. Alrighty, let's get back out of here, apply. At this point, as far as Camelot is concerned, we're done designing the roll bar. Now, there are certain deficiencies in Camelot. Like I said, it's a work in progress. We've got a lot to do. And one of the things that we really want to add in 2023, of course, is a feature tree and a history tree. We don't have any of those right now. So what I do is as I create a frame, when I hit certain milestone points, I will save that frame or a job and I'll give it a name donating the step that I'm at. So like right here, for instance, I'll come along and I'll say save active view as, and earlier I said braced. Well, this time I'm going to change the name to coped and I'll say save. Now, the reason I did that was because since we don't have a history tree or a feature tree, if I do something that messes everything up, I may have to go back in my past. And the only way I can do that is a saved file. Now, in 2023, we will implement a complete history tree. So let's just say, for instance, you wanted to suppress a feature. Maybe you didn't want to cope something or you didn't want to split a tube. You would be able to suppress those features or go back in time with your history bar and repair your part. Right now, for instance, I'll show you one of the deficiencies in Camelot. Like I said, we think it's a very, very good program, but clearly there's a reason why software companies put out updates because they keep adding it to it and we got a lot to do it. But let's just come along and take this part here and I'm going to change this part to 1.5 inch tube. Remember I mentioned earlier you could do that. We're going to hit edit. Okay, and what I want to do is I want to modify the profile. Now, first thing I need to do before I do that is let's go over to select active profile and let's pick our 1.5 inches. Now this time I'm going to sort by the product group and there is our 1.5 inch 5.5 radius. Remember we talked about that die, and I'm going to apply and close and it verifies right here that we've got the right size. I'm going to go ahead and modify this tube here and it tells you that it's a 125. I've already got my profile selected, so I am going to apply to selected tubes. Now let me zoom in here a little bit, and what I want you to do is I want you to be able to see it. Now if you notice, there's a light red tube superimposed over the dark red. That's basically telling you what it's going to do. So let's go ahead, apply to selected tubes, give it a second. It's thinking about it. There you go. And, oh, it made a liar right out of me. In a previous build of the software, it would have deleted these copes, but this time it kept it. Hats off to Guido for doing that. He no longer works with us, but he did it. So thank you, Guido. In the past, it would have gotten rid of those copes. You have to put it back. And that's why we need a history tree, which we will be implementing in 2023. But right now, it seems to be doing awfully good. All right, so let's apply and close. And as I mentioned, we're done coping. We're done pretty much with our frame. So let me go ahead and show you a couple other things we can do with the finished frame. Let's go ahead and say you wanted to make one of these parts, take it out to the machine and cut it. How would you do that? We're going to need to make a job. Now, what I'm going to do is I'm going to select this part here, and I am going to right click on it and make a job. Now I could have also come up here and said make job for selected items, but I'm going to make a job right here. Now this green progress bar down here is just showing you that Camelot is thinking about this. Alrighty, now it's asking us for a job name, and I'm just going to put this down as the horizontal, whoops, caps lock. All right, I'm not a horizontal, let's see. Horizontal tube. We'll just call it that, okay? Get rid of the R. Okay, there we go. There's our horizontal job. Now, all we need to do, add an operation to it. So I click this little green button right down here, and I'm going to go ahead and select the quick make operation for all layers. And there we go. At this point, we can now nest the tube. So let's just say, for instance, we wanted 2 of these. I'll change the desired number of parts over here. If I move this over, you'll see it better. The desired number of parts to 2. And let's go ahead and nest it. Now, as soon as I select nesting up here, it's asking me for the raw length of new tubes. And that's because if, let's just say I wanted 100 of these, it's not going to fit on one tube. Well, I could come along over here and tell it that our raw tube length is 240 inches. And I'll show you why that's important. In fact, you know what we're going to do? We're going to make a big change here. Let's close this. Let's go ahead and tell it we want 12 of these parts. Is that, yeah, that'll work. 12 parts, okay. We're also going to come up here to tube nestings, and we're going to hit the plus button, and we're going to say we have a piece of tube out there that's 80 inches long. Let's go ahead and add that to our tube cube, but we're not going to tell it anything else. Camelot is smart enough that it's going to tell you how much more tubing you're going to need to cut all these parts. Let's go back to our nesting panel and select Nest Tubes. We got a raw length of 240, which is a standard length of a raw piece of tubing, and let's hit Nest. Notice what it did right here. If I select the first nest, it figured out it could get 1 piece out of that 80-inch piece. But on the others, it came along and it said that I can only get 3, and out of that tube, I'm basically going to use up, let's see if I could zoom in here, daggum near all of it. I mean, we got lucky on that right there. But typically, it's going to get 4 parts out of that. Then we got this one, and on the last one, we're only going to get 3 parts because that's all we need. So that's a really nice feature of Camelot. Now, let me go ahead and close this out. The next thing we need to do is go ahead and generate the G-code to take out to the machine. So we're going to go over here, and we're going to select Run Post Processor. It's doing its thing, and there's your code right there. Now, what happens is if you select different nestings, there's different code for this. So in the real world, this particular one here, it got the one that did the 4 pieces. It's going to be the exact same code as this one right here. However, Camelot does not know that, so you know, it's just something for you to know. But if we look here, this is a separate G code right here. Now, we can go along and we could save the G code as horizontal tube. Now, if I do that, It's going to ask me where do I want to save it. So I'm going to go ahead and put it in the folder that I'm using right now to create this. So let's say, okay, open containing folder, sure. Alrighty. Now, if I come over here to this folder, you could see where we now have horizontal tube 1.ngc. ngc is the file extension of the G code that the rotary cutter, the JD squared rotary cutter, is going to use to cut this tube. Now, if you notice, there's 4 of them because we have 4 individual programs. Now, what I could do then is literally take those parts and head on out to the machine, load them, and start cutting my tubing. I'm good to go. Now, let me go ahead and show you how to process one of the tubes that was bent. This time, we're going to process this particular bent tube right here. Let's go ahead and right-click on it, make a job. Now, this one, since it's got bends in it, it's going to show you where to put the tube in your bender when you go to bend it. It's doing the processing right now. It's basically calculating after the stretch of the tubing, the normalization of it, everything else like that. And now it's asking me, it wants to know, what do I want to call this? So I want to call this the front up tube. You know, no, I'm not very good at naming stuff. So anyway, there's your tube right there. Now, if I zoom in, you could see the number 2, 40 degrees. I can go to, there's your part right there. We haven't nested it yet, so there's no nest view. But that's your part right there. Now, in that particular design, right here, we got 2 of those tubes. So let's just go ahead and tell it right off the bat that we want 2 of them. Now, let's go over here and we got to add our operations. And what we're looking to do here is I'm going to go ahead and make operations for all items. Now, if I select on it, I got my markers. See, it goes cyan right there. That means that's the cut lines or the marking lines. Then I have my start, and then I have my end cut. I don't really want to put the markers down first because I don't want to waste time running up and down this tube. So I'm going to hold down the left button on the markers, click on the mark, and I'm going to drag it down to, I think I dragged it too far. There you go. So now we have start cut right here. Then the machine, the rotary cutter, is going to mark all your markings. Then it's going to cut your end cut right there. Now, if we zoom in a little bit, obviously the black is what the machine is either going to draw with the Sharpie magic marker or it's actually going to scribe with the pneumatic scriber. It's your choice. The red is that lead-in value, that 7/8 of an inch lead-in I was telling you about earlier. It does not get bent. It's just showing you that when you load this tube into your bender, this outside line here, because there's 2 lines. One of them is going to show you where the bend's going to start bending. The other is going to show you where you need to load it into your JD squared bender or whatever you got. So let's go ahead and do that. Let's go ahead and nest it. We told it we needed 2 of them. And there you go. And that is our tubes right here. And if you zoom in, you could see what it's going to mark right there. And that would be the marking layer. So at this point, we can close this tool. Let's zoom back out. And you can see we got both our parts. Once again, we're going to run the post processor. We got to give it a name. Let's call it, it's already named it for you, the front upright tube. And because it only generated 1 file. If it generated multiple files, you're going to probably have to put the name in. But let's go ahead and say save. Now we have our G code here. We put that on a USB drive, that file, head at the machine, cut our part. Now let's go ahead and close this out. Sure, I'll save that job. It's asking us, do we want to save it? Because you don't always need to keep generating G code. Just save the G code file. So the next time you make this cage, just take the G code out there and cut those parts out. Obviously, your naming convention is going to be important. Camelot has features in it to where we can put part numbers on your part and everything, subject to another video, but just keep it in mind. We can actually put text, logos, things like that on the tubes also. All right, now, this time, let me just show you another feature. Let's just say we wanted to verify that tube being bent. I'm going to go over here. I'm going to select the tube. Then I'm going to go ahead and bend selected tube. There it is right there. Obviously, it's showing us all of our markers that we talked about earlier. But this time, I can pick a couple things. I see the word reverse is misspelled. We'll have to fix that. I could pick what kind of bender I have. Rotating die would be like a JD Squared Model 3, Model 32, anything Model 50, a 52, 53, 54, etc. A static die, and the rotating die, the die is going to rotate. The static die, it's not going to rotate. The die is going to stay stationary, and that would be, for instance, for our bender, like a Model 4 bender. Let's go ahead and run this back and start it so you can kind of see what the deal is. I'm going to zoom this out a little bit. And let's see, what am I doing right here? Come on, stop. Stop. I want to start it. Why am I not bending? Oh, shoot. Yeah, maybe my in-laws are right. Maybe I'm not the smartest or the smartest star in the sky. Yeah, they're absolutely right. No, what it is, I'm in the wrong tab. I'm in the Dimensions tab. I need to be in the Animation tab. There you go. My bad. Anyway, if I run back right here, you can see where it's animating, but the die isn't rotating. Let's go ahead and stop it, run it back, and select the rotating die. Let's just say you had a Model 3 or 50 or something like that. Now, if we hit it, you'll see the die actually rotate. Now, you can see what's going on. You see why it rotated it? Now, let me go ahead and show you something here real quick. I'm going to stop that. I'm going to run it back a little bit and zoom in. You see two lines right here on each side of the tube. And what they're for is if you need to use this in a bender that isn't a JD Squared bender. One comes to mind is a Mittler Brothers bender, bends in the opposite direction. It bends counterclockwise, where a JD Squared benders and most other benders will bend clockwise. So we had a customer who's got not a Bailey bender, a Mittler Brothers bender, and said, hey man, I can't read the marks. They're underneath the die. So what we did is we modified the program. We put the marks on both sides of the bend right here. Now, there's a lot of other things you can do when you go to actually create this tube. For instance, I could tell this that I want to bend this left or right, like I want to flip it around or whatever. Check out that video when it talks about bending tubing and how the rotary cutters handle that. We don't want to clutter this video up too bad if we can help it. Anyway, that's how you would animate it. Now, the last thing I'm going to go ahead and show you is let's apply and close right here. Let's get out of this. Let's just say we want to process all of these tubes at one shot. We're going to select Make Job for all items. Okay, now this is an extremely time-consuming operation. I have a very, very fast computer right there. I think it's running like almost 5 gigahertz, got 64 gigabytes of RAM, very good graphics card, very fast computer. Whenever you're working with a CAD/CAM program, you're going to want the fastest computer that you can afford, save you a lot of time in the future, because what it's doing right now is incredibly math intensive. Now, I know that I could have skipped forward in this video and made it look like Camelot was instantaneous, but that's not fair. Excuse me. I want to give you an idea of the real world experience with Camelot. So we're going to let it run out so that you can see. It'll be done here in a few seconds. It's not that bad, but there's 12 tubes that it has to process. The bent tubes, it has to straighten them out, figure out how much tubing it needs, the whole bit. So let's just take a sip of our drink, and it should be done here pretty shortly. Hope you're having a great day, by the way. I'm getting ready to leave for a trade show here in a couple of days. I'm pretty excited about it. Hurry up, hurry up. I remember a comedian, Stephen Wright, said that one of his routines, he said he put instant coffee in a microwave and almost went back in time. That's pretty much the way I am. I'm thinking, man, I need to go quicker here. Okay, what it's done, it's done. And if you look right here, it's got these tubes up, and it's asking us for a name of a file. Now, one thing Camelot isn't doing yet, but I'll get it to do it here as soon as I can. It's not suggesting a name for the job that it's doing, and I really needed to do it. So we're just going to call this, though, we're going to say tube underscore 1.5. I think that's the 1.5 inch tube we're looking at. Like I said, I'll fix that later. Now let's go ahead and put that in our folder once again. All right, so we're going to say save. Now it's going to ask me for another job name, and this time I'm going to name it 1.25, and we'll say save. Okay, there you go. So you've got a 1.25 job here, and you've got this one here, which is the 1.5, and I actually got it correct. Remember, the 1.5 inch tube, if I go here to the main frame, is the ones that we're bending, and that is what is being shown right here. This is your 1.25 inch tubes. Now, let me talk about these tabs up here a little bit. If you look at the part view, you're going to see the parts that it's cutting for this job out of that main frame. There's nothing under nest view because we haven't nested anything yet. Under tube view, you see the individual tubes, and by clicking on it, it will show you the different tubes. Now, another thing you can do is go to part view. You can actually click on the tube right here, and it will highlight, there it is, that tube right there. All right, let's go ahead and make a job for these 1.25 inch tubes. As we did with the single parts, we're going to go ahead and add our operations. Click the button. And I'm going to hit select make operations for all layers. I could have done them individually, the start and the end cuts, but I'll just hit the quick button. Let's give it a second here. And there you go. So our operations here, if I go back to tube view, there's our start cut operation, there are our end cut. Now Camelot has done this for every tube that is 1.25 inch. Now at this point in time, all we have to do is nest our tube. So we click nest up here. You know, it did this to me earlier. I think we've got a slight little bug here. I'm not 100% sure what it is, folks. I will find and fix it, but I do know the workaround. Let's go over here to the 1.5 inch job. Let's go ahead and do the operations. I'll hit make operations for all layers. Like I said, I'm relatively, I try to be a real honest guy. So if I have issues with our software, I'm going to tell you what they are and that we intend to fix it, and we just saw an issue. Now, one thing I'm going to do in operations on the 1.5 inch tube, if you notice, this is the order of operations right here. So the machine first is going to do the first operation, which is mark your tube. Then it's going to do the start cut, which will be the end cut on your tube, furthest away from your chuck. And then it's going to do the end cut. We don't want to do it in that arrangement because let's say your markings are near the chuck and your tube is 20 foot long. Who the heck wants to be running up and down this 20-foot piece of tube? All we got to do to fix that is I'm going to click on the start cut. I'm going to hold down the left button and I'm going to drag it up to the top. Now, the cyan right here is denoting what we're doing. And then we've got the middle cuts, the markers, and then we have the end cuts. We're good to go. Now, on the markers, I'm going to double click on it to edit it. And we don't want to cut that with a plasma tool, do we? We want to mark it. Now, I'm not going to scribe it. I'm going to mark it because I don't want the marks to come through the powder if we powder it later. I could have done either scribing or marking. It would have done either one, wouldn't have mattered. But we're going to go the marker, which, by the way, we use Sharpie magic markers in our machine. They work really, really good. And there you go. Now, if I go to start cut, what I didn't show you earlier is you need to pick the consumables that you're working with, and it picked the 65 amp shielded, which will be fine for what we're doing because it knows we have a Power Max 85 out there. Okay, there we go. That's that one right there. Now, if we nest it and we go ahead and hit nest right here, see, it's working fine. It didn't work a minute ago on the other one, but it's working fine here. I have no idea why that is, but we will fix it. And here you go. This is showing you all the parts that you're going to need to cut out right there. Let's move it over a little bit. Now, these are 1.5 inch parts. So if we go to the first nesting, remember, that's the one that's going to have all of your marks right here in order to put it in the bender, what you want to do. Now, I don't think I mentioned it. If you notice here, I think I did. There's two lines, and that way the tube could be put into a bender that either bends left-handed or right-handed. I think I mentioned that. Anyway, we're good to go. Now, all we would have to do is close our tool here, come over to Run Post Processor. Give it a second. It's generating the G code that we're going to put these files on our USB, take it out to the machine. Now, one thing I would like to add is if you'll see the code change right here slightly. If I click the next nesting, if I click between them, you can see the code change. You really see it in this area right here. That's because there's two different files. Now, if I come along and say save the G code, it's saying it brought up the name. It suggested tube 1.5, so I'll say okay. And then it's asking me where do I want to save it. And clearly we want it back in the same area that we had before, and open it. And if I look, here's our two programs right here, our 1.5 inch. We have that done. We're good to go. Now, let me show you the bug that I just discovered. We're finished with the 1.25 inch tube. Let's go back to our we're finished with the 1.5 inch tube. Let's go back to the 1.25 inch tube. And what I just discovered is if I hit nest tubes, nothing happens. Have no idea why. Clearly that's a problem in Camelot that we'll have to fix. But watch this. If I close out the first tab that we did the job on, you want to know if I want to save it? Sure, I want to save it. In case I want to do this part again. Go back to the tube. Now watch what it'll let me do. Huh, wild, huh? Anyway, I just selected nest tube right here. I'll hit nest tube here. And there you go. If I zoom back out, there's your nested tube. It says we only need one piece of tube for it, so we're looking good. Part view, once again, this is showing you all of the parts that it's going to cut out over here. And I could have changed the desired number of parts here, or I could have come over here. In fact, let me show you that. I'm trying to be complete for you. Let's get rid of that. This time, I want to override the parts, and I want 3 of each of those of the parts that we have over here. Let's go ahead and hit nest again. Shouldn't take that long. There you go. Now look how many parts that it says we're going to need, because it multiplied everything here in the desired column by 3. So keep that in mind. If you're going to do a job and you save the job, open the job up, and let's say you're going to build 5 of these roll cages, just tell it you want 5, override the number of parts to 5, and you'll have enough parts for 5 roll cages. Okay, that's pretty much it. Other than, of course, I would have to do run the post processor. We'll do that so I could show you one last feature, and then we're going to call it a day. And what that feature is animation. So if I come right here and I select the animate button, you saw the bending animation. This is actually the cutting animation, and there it is right there. So if I hit animate, you're going to see it. It's going to start rotating around. Now, I want to stop it because I'll show you a trick in Camelot where you can kind of cheat it, speed it up a little bit. And that is just click over here and then just hit the down arrow button. Notice how much quicker it's going through. And this is allowing us to verify the order of cuts. I mentioned earlier that we have the ability to reorder the cuts that you do. However, in the real world, you're going to want to go from this end of the tube here to this end of the tube. And a lot of times I like to verify that to make sure that that is what we're doing. And believe me, that is what we're doing. Anyway, I think we are done with this example. Now, it's asking me, do I want to save my 1.25 inch job? Yeah, absolutely, I want to save it. So there's your part right there. We've created the roll cage. We've coped it. We split tubes. We've done a lot right here. There's a lot of features that are still in Camelot. So check out other videos, and I am making playlists to help you out to find this stuff quickly. So you would go to the JD Squared, I don't know what YouTube calls it, our page or whatever, and then look for playlist and find playlists that have the word Camelot in it, and that will be where you find all the information. Anyway, let me zoom this back out here so I could thank you properly. Thank you very much for watching. This video was made as a suggestion from a new customer, and we like these suggestions. I'm going to be spending the next few months literally just as much as I can, documentation on the rotary cutter, the XR6. We're getting ready to start looking at UL and CE and CSA certification. So I've got quite a few months. So if there's anything you would like to see, please email support, and I would be happy to do it for you. Hell, that's my job, right? Anyway, once again, I say it all the time. Thank you very much for your support. If you like what you see, hit the like button. If you don't, no big deal. It's not like I'm going to compete with Mr. Beast. But we want YouTube to notify you if you've got our machine at something else coming up. So you may want to subscribe too. If not, it's cool. I'm fine. I don't make any money on YouTube. I don't care. Anyway, I really appreciate you taking the time out and watching the video. And I hope I've presented it in some kind of orderly fashion where you actually digested it. I hope you have a great day. Goodbye.